Hi there, it's Sasha here, creator of Coding Rooms, and I'm joined by John Hajel, who teaches in the San Francisco Unified School District at George Washington High School, Comp Sci, AP Comp Sci A, and AP CS Principles. And today we're going to be talking about teacher credentials, and of course there's a lot of different takes on that, and then we'll also be talking a little bit about robotics. John's a big user of FIRST Robotics, so we'll dig into that a little bit. I'd love to hand it over to you, John, if you can share a little bit more about how you got into teaching CS, where you're teaching now, and also you're a Coding Rooms user. I'd love to hear how you're using Coding Rooms in the classroom.
All right, great. Thanks, Sasha. Yeah, I teach in San Francisco. It's a public school, fairly large public school on the west side of San Francisco in the Richmond district, if you're familiar. I teach AP Computer Science A, and I've taught that for about 7 years. And principles, since it's been a principles course, which I think is about 3 or 4 years now. So I've been teaching that as well. This is teaching as a second career for me. So I was in industry for a while, did a little bit of coding right out of college I had a computer engineering degree. And then I was in sales and marketing probably for the bulk of my 20 years in industry doing that.
Awesome, awesome. And before we get into our first topic about teacher credentials, which has been, or continues to be, I should say, somewhat of a controversial question, what was it like for you switching, or basically starting a second career, and having that industry experience and then becoming a CS teacher? And I know there are some California-specific nuances to that answer, but if you can highlight them, that'd be awesome.
Yeah, well, it's one thing I would say as a person that's switching careers from industry to teaching, it's your high school experience is not the same. You know, I went to high school a long time ago in New Jersey in a upper middle class area that was well-funded schools. And then when you come to a different area and with different types of students, different ethnicities, different backgrounds, it's a totally different experience going forward. So it was a shock. It's not what I expected. You know, you have this preconceived notion about how you're going to teach and how great it's going to be and everything like that. And then when you go into student teaching and then you're teaching, it's a different animal. Still very fulfilling. I'm so happy I made the change. My wife always says, "You're so much happier now," and I really do feel that way. I'm very fortunate to be a teacher. I'm very lucky to be a teacher. So I'm very grateful that way. You do need, like a lot of, each state's different. You need to go back and get your teaching credential. In California, that's usually 1 year, includes some student teaching. Sometimes it's longer, especially if you want to get a master's in education in addition to that.
Mm-hmm. And how have the teacher credential requirements for CS changed since you initially got into teaching CS?
Yeah, so when I first got into teaching, you could teach computer science with one of 3 ways. You can have a math credential, so you can teach math. And I did teach math prior to teaching computer science for a few years. And you could have this thing called supplementary authorization in computer science. And at the time, it was only available for people that had coursework in computer science. So if I had it in college and things, and there was not a real good established way to get it. And then the third way is having what's called a CTE, Career Technical Ed credential in that. It also requires some coursework. Recently, there's been a new law. I don't know about it, but you can actually, there are programs at colleges. I know San Francisco State has one where you can take some coursework, and then you should get the new supplementary authorization in computer science. You can get that, and now you're authorized to teach that.
I see. And as we dig deeper into the credentialing process, broad strokes at a high level, what's required to get these various certificates?
Oh, okay. So for math, You either have to pass a test to say you're qualified to teach math, right? It has nothing to do with computer science, you know, the normal geometry, algebra, calculus type things. And then you take the test, you finish your credentialing program, which includes student teaching, and then you can teach computer science without any knowledge of computer science at all. You'd be allowed to legally to teach computer science. Uh, the other credentials require some kind of, either the CTE requires experience in the field. So if you had some experience coding or something like that, you could teach right away, but then you would have to eventually take some coursework and get your full credential. You'd have like an emergency credential and you get your full credential eventually. This new one is requires coursework. I think it's about, don't quote me on, like 4 different courses in computer science, and different colleges have different programs. San Francisco Unified School District has a partnership with San Francisco State, for instance, where they are training current teachers to get this credential. They're paying for it through, I believe it's through a grant through the National Science Foundation. So they're trying to get more and more computer science teachers qualified to teach computer science, and credentialed to teach computer science. That's just one way they're doing it.
I see. So we're talking about a lot of credentialing, a lot of different ways you can get credentials, and a lot of different ways that that's changing. I'd like to hear your input on a more sort of meta question, which is, what's the point of a teacher credential? What does that really give us? And sort of putting that aside for just a moment, kind of with understanding that, broadly speaking, if you want to teach computer science at a university, for example, you don't need a credential, or obviously you need credentials, but there's no like set, you have to take this exam and pass it at a certain level, right? Or have, you must have taken this course with notable exceptions, obviously, but that doesn't exist. And then certainly for industry, you can go to a boot camp and interview, or you can just kind of hack your way through it and get a job. So I'm wondering, in high school teaching specifically, why you think a credential is necessary? Like what purpose does it specifically serve? And is it good? Should we keep making new credentials for computer science teachers, or should we change something about the way that we issue these credentials?
Yeah, I think credentials in general are good. It makes sure that everybody's qualified to teach. I mean, if it's English versus math versus if it's elementary school, I think it's the training that you get student teaching and also through the universities that offer credential programs are very valuable. I learned a lot. I realized, what I thought the students would react to me or how they would react to me is not really the same one thing. I think that's important. I learned a lot of things about, analysis of development and classroom management and things like that in my credentialing program. So I think I want to speak, those things are necessary. It's also a good point where not everybody finished their credential program, because it was a chance for you to realize, okay, this is not for me. This was an opportunity to go through the program and say, okay, teaching is not for me, and they didn't. Some didn't make it through. Computer science skills in general, that's a tougher one. But I think one of the problems is there's just not enough people with computer science knowledge willing to teach, right? I mean, we know that as a society, people that have computer science knowledge that can code, they can make a lot more than if you were going to teach it as public school, for instance. So there is that shortage of people that are qualified to right off the bat to teach computer science. So these programs like this new supplemental authorization is one way to bridge the gap. We can take somebody with a math credential or math background, or somebody with a science background, and we can give them what they need to get going on it, learn a little bit about the pedagogy of teaching computer science as well, and get them going on on computer science. I think there's one thing that like some of the teachers that I work with that are math teachers, they are math experts, right? They are, you ask them something about, calculus, and they'll answer it within seconds because they know it for things. I think we have to get away from that for middle of computer science, especially if we want to fill all the positions that we need, and we want to grow the number of computer science teachers in the country. And instead, it would be like, if a student asks you a question you don't know, I don't know, but let's see if we can figure it out together. Or you're more of a facilitator instead of the sage up on top of the stage trying to experiment. So we have to kind of model what our credential program is to the need and what the supply is, I guess, on this. And I think it's a good thing to have these new programs to get more people involved in computer science. That's my thoughts on it.
Mm-hmm. So the credentials that we mentioned, that we talked about here, like for example, even the supplemental authorization, to what extent did those cover coding skills?
There is, I would say there is coding skills. They actually have to learn coding. I know I didn't take it because I already had a program. I know it was in math, so I know a little bit about it. But there is some coursework in pedagogy, but there's also coursework in coding. A friend of mine who has this particular program, she did a Python class, and it's probably equivalent to the CSA type of a class. But you remember, not everybody's going to be teaching CSA that needs to know details about Java and things like this. So a lot of it is, middle school and the 9th and 10th grader level thing. So these teachers can teach that, and they can teach it very well. Could they teach Java very well? Probably, but it would take a little bit more work for them.
I see. And actually, you had an interesting point about the different levels that actually need to be taught. So credentialing is interesting because it doesn't seem like the credentials are linked to the level that you're teaching. Is that correct?
There's, to a broad sense, they are, right? You can teach secondary, which is middle school and high school, and then there's another credential for elementary school teachers.
I see. So, but given that what you would teach in a 6th grade class is so drastically different from what you would teach seniors who are about to go to college, class full of like 17 and 18-year-olds, do you think that's I'm sort of personally interested in that specific value that the credentials signal, right? Because if there's a lot of different approaches that you could take, but the way I see it is like, okay, so you have this particular credential, and then it's supposed to signal a certain set of abilities. And I'm trying to understand better, is it primarily how to manage a classroom, or is it primarily, hey, people don't understand recursion. Here are some specific tactics that you can use to explain recursion. And as someone who's not, didn't go through that certification process and isn't certified to teach, but is ostensibly at least a sort of mediocre programmer, I'm trying to understand how all those things come together.
I think to become a good teacher, you need to have both. You need to have the subject knowledge, and you need to have pedagogy. You have to understand pedagogy, classroom management, how to, all of that together makes a good teacher. I think there's some utility being knowledgeable in the subject matter, but I don't think it's 100% necessary. If you're a good teacher, and you know a little bit about computer science, you could teach your class so they get something out of it. I think the more some knowledge is definitely necessary. I wouldn't put somebody with no computer experience whatsoever into a class and try to have them teach computer science, but I think we have really good, high quality computer science teachers that aren't experts in computer science.
I see. Have you seen it the other way around? I mean, perhaps you might be more of that, have more of that background, right? Since you came from the programming or coding, let's say, related industry. Does it work the other way, where you can have someone who's a fantastic engineer and then they struggle with teaching, and how do you reconcile that?
Oh yeah, I mean that happens a lot. I mean that like the credentialing program I was in, they were they were engineers that wanted to teach primarily math at the time, and there wasn't many computer science when I was in there wasn't much opportunities to teach computer science when I was in credentialing program about 10 years, and super dedicated, super, I mean, engineers or mathematicians, and um, they just couldn't get to the how to engage students, right? And there's not just one way to engage students, but they couldn't engage students, or it was too difficult for them to engage students. So they weren't very successful doing that. But and on the other hand, there are people that didn't have a great knowledge of whatever subject matter they had, but they learned it as they went. And long as you can manage kids and you can make them enthusiastic about the topic, I think you're going to be successful.
I see. So let's say for the newer instructors who maybe come from teaching math, they don't have much of a coding background.
Mhm.
What resources do you think could be helpful? Because it sounds like that's the predominant path, right? Is that you're at non-CS background, and you're either mandated or personally interested in teaching CS. So beyond the certification, what are some useful options or tools?
I think the good news is, I mean, for 10 years now, they've recognized that there's a demand for people to be able to code, and the people to be the National Science Foundation, the universities have realized we need to get more computer science teachers out there. So there's quite a bit of resources out there. There's online, um, curricula. There's online ways that you can learn. There's teachers. There's training. All sorts of things that are out there that are primarily free. Where you wouldn't see that necessarily be free in other subjects. If you think about all the curriculum for computer science principles out there, almost all of it is free. Almost all of it's free. All of it has some kind of training. And at the time when the training was mostly free, but now you can get grants to go for training and things like that. So there is definitely opportunities to become a computer science teacher if you want to, above and beyond what was maybe there previously for some of the existing subjects like math, English, things like that.
Mm-hmm. That's an interesting point that you raised about the free resources. What are some of those particularly useful ones that you've come across?
Oh, well, I think a lot of the the computer science principles curriculum, which curricula I guess is free. And the way the principles work is there's not just one AP curriculum. There's lots of different ones. You can choose any one of them to teach your course that way. In fact, you can mix and match. I take things from code.org's curriculum, and I teach primarily in Beauty and Joy of Computing from UC Berkeley. But you can take aspects from other things. It's free. Code.org has lots of great resources that you can take from them, videos and little widgets online and things like that. So that's just one example where you can find some online things. As far as CSA, the Java course, and by the way, there are similar things that are free resources for younger, not necessarily AP level, for grade school, middle school, and lower high school, like ninth grade. Things like Exploring Computer Science or Computer Science Discoveries, and there's others as well. But for the computer science A level, for the Java classes, there's CS Awesome. It's a great textbook / it's online textbook with interactions. I really like that. I switched to that this year, given that we're 100% remote this year for our students, and I like that idea, and it's been really successful. Having some computer knowledge allows me to answer their questions when there's something that's confusing in CS Awesome, for instance.
I see, I see. And these free resources, how have you found that they compare to paid resources? I mean, there's of course a huge variety of different curricula out there. So how do you kind of go about choosing a good free curriculum?
Yeah, I mean, word of mouth, I guess. You know, I found CS Awesome from one of my coworkers that works in the district but another school. You know, it's definitely it's 100% online. I did have online textbooks before, so that wasn't the issue. It was the fact that it was interactive. I could make assignments through it, and again, I was free on that portion of it.
Mm-hmm. I see. And actually, this is a sort of tangential question, but how many computer science teachers are there in the San Francisco Unified School District?
Oh, there's quite a bit. So they had a big push a few years ago to get more computer science, and now I only deal with the high school level and somewhat on the middle school level because we have meetings with the middle school teachers. But there's a whole level of teachers teaching it from kindergarten up through, you know, 6th grade, and then I know some of the middle school teachers as well that are happening. So I don't know. I'm 50, 30, somewhere around that. I'm just thinking about the last big meeting we had in person. There might have been, you know, 50 people in the room. So there's quite a bit. The way that they work at like the elementary, the middle school level is the teacher would be a traveling teacher. So he or she might teach at 2 different middle schools, you know, and then the middle school class might be, you know, you might get 6 weeks of it a year, 6th, 7th, and 8th grade or something like that. It would go from there. So depending on the schedule, and each school has at least had a different schedule. They're trying to standardize schedules and bell schedules, things like that.
Gotcha.
But at the high school level, there's probably 20 of us, 15 of us, something like that.
Mm-hmm. I see. Yeah, that's pretty interesting. I mean, of course, kind of. I don't know. Actually, is CS a hard requirement in your school, in high school?
No, the way it works for California, anyway, it's not a graduation requirement for getting a diploma from high school. It is, you know, there's certain requirements to apply for UC's, University of California system, and the APCS principles is actually a 3rd-year science course. So if you're applying for a UC Berkeley, UC Davis, et cetera, UCLA, you would get your transcript would get a little bump because you have a 3rd-year science course. You're taking at least 3 years of science beyond the required biology and chemistry, for instance. And then AP Computer Science A, and by the way, this is all rather recent. Computer Science A is a math course. It's a 4th-year math course. So it'd be on par with the AP Calc or AP Stats or some other non-AP, but a 4th-year course.
Mm-hmm.
Or as UC admissions, but not for graduation.
Understood. Do you think that that's positive, like grouping CS in with math all the time? I'm hearing this as a really common thread, and you taught math before, so really interested to hear what you think about that.
Yeah, I don't have a strong opinion. I know a lot of computer science teachers have a very strong opinion one way or the other on this. I've heard it both ways. I think there are some students that kind of like, you know, I don't know the word is min-max their transcripts, right? So before it was what's called a general elective. It didn't have the clout, I guess, on your transcript as a math did or a science did. So if students had to choose between taking AP Stats or computer science, they would take AP Stats because it counts as math. Or if they would take AP Physics instead of taking AP Computer Science Principles because they were trying to get into the best UCs possible. So this took that away, which is nice. Is it appropriate? Are we like, is principles, you know, a science? That's something I don't have. I don't have a real strong opinion with one way or the other. I did notice by doing this I got more participation from the female students as well. So that was a positive thing from the change to make it just a general elective to a math or a science elective.
Oh, that's really interesting. Because like the one thing that came to my mind immediately was that if it were, and I don't know actually the way that this is really positioned with students, but I'm thinking for me, I was pretty impartial when it came to math. It's like, you know, it's the thing I have to do. Wasn't super excited about it, but computer science obviously, it's like my life, it's all I was thinking about. So if I thought it was like too heavily grouped into math, I think I might have been less interested in taking the course.
Mm.
But now that I think about it, you're saying that like it's grouped in when you talk about grades, which maybe is different in terms of overall like subject area.
Yeah, I mean, it didn't change the way I taught. I didn't change the curriculum. I just slapped a new, what's it called, a letter. It's A through G in California.
Mm-hmm.
It didn't change much that way. It's just, it attracted some students that were interested in bolstering their transcripts. And these are students that um, would do very well in computer science, but they just didn't see it as a possibility because they didn't see it on their transcript.
I see. And there's kind of a controversial take on this that you could have that I think is sort of worth entertaining purely for the purposes of discussion, which is that APCSA is a relatively heavy like coding course, I would say. I think that if you're not genuinely interested in computer science, you probably shouldn't take it. Do you kind of agree with that?
Uh, I don't know. I think there's some students that are not, they're not, they don't know what computer science is really. They don't really know what it is, right? I mean, and to be honest, we teach principles and it has a lot of other aspects other than coding, for instance. It has, understanding the internet and how, technology affects society, which are all great. And it's a great survey course that way. Um, Ultimately, we want them to code. We want to hook them in. If it's principles that hooks them in because they can see what they can do with it, that's great. If it's CSA and they're learning to code and they like the puzzles, I mean, I get a lot of that. Like, I love this course because it's like a puzzle. We're trying to figure out how to solve this problem, and I get it. And then I'm still going to major in biology, but now I can go into my bioinformatics class and I'll be that much more prepared for it, or something like that. So I don't, and CSA is certainly scary because it's new for students. Like I tell the students is they've had, by the time they reach me, they're 17. They've essentially had 15 years of math, their whole life. And every year they just keep adding more. This is just like, bam, here's a totally new topic that you may have never, ever seen before. And it can be daunting for it. So I think the idea of offering it at younger ages is going to help quite a bit. But in general, I think it's a good thing if they take it, if they're willing to take that challenge. And I think it will help them, whatever career they decide to, or whatever major they want to go into. I think computer science is helpful that way.
I see. I wonder though, I mean, because you end up having to serve a really, really, really broad set of students and corresponding sort of interests and aptitudes. Does that, or do you think you're able to keep the course effective for kind of the people that it was initially designed for? And I don't know if this sounds, I mean, I don't know how exactly this sounds for you, but it's like what I would love to see is like, instead of having 2 CS courses, why don't we have like 6? And then you can actually let people do what they want to do. Like that's kind of my dream. And I know that that's not maybe practical, but it seems like it might actually be negative to like loop in a bunch of people who really have no interest in coding as a major, as a career, and then kind of feel super bogged down and disinterested by I don't know, bubble sort, all the different things that you end up having to do in APCS. Actually, I don't know if that's still on the exam, by the way, searching, sorting.
It is not bubble, merge, and search and selection.
Yeah. So even even hacking on like a sorting algorithm, like I really think there is and I don't know what exactly to say about this right now, but I feel like coding is so, as you mentioned, so different from literally everything else you do in school. And to just, and I know APCSP is literally meant to do this exact thing, which is bridge from all the general education that people have into being able to code. But I wonder whether or not this push to have everyone code is actually the best thing. It's like there is a certain there's a certain value for people to self-select, right?
Mhm. Yeah.
And selection bias isn't bad in and of itself. Like inequity is bad, but people deciding not to take CS is not bad. Like, I think there's plenty of people who it would be the worst decision if they decide to do a CS major in, or take APCS. Like that's not what you should be doing with that. That's not what you really want to do. And so one of the things that I genuinely am kind of concerned about with a lot of the CS for all is, to what extent is that is that addressing the real issues, and then to what extent is that also hindering people who really want to be career software engineers, or be in the tech field, and then are kind of discouraged because they're in a class with a bunch of other people who don't want that, but the class is being taught to them. Does that make sense? I know
Yeah.
that that's probably a super, like, percentage wise might be 1 or 2%.
Yeah. I mean, it's a problem we struggle with pretty much every day, and every year. The Java course, and just full disclosure, I want the kids to do well on the AP exams, both of them, the CS principles and the CSA. And the CSA has a lot of curriculum to get through. It requires homework. It requires students trusting themselves that they're going to get the topic eventually. And we have students that don't make it through it all the way, right? They don't make it, they drop the course, and things like that. So it is concern, it is a concern, but I want them to be prepared for the college level computer science if they want to major in computer science.
Mm-hmm.
Principles is much friendlier, much more friendly, I guess, in that it's for equity reasons. There's not a requirement to code outside of class, which is great because so not everybody has a computer at home, not everybody has internet at home, things like that. So and the curriculum is very not just it's got some coding, and of course the coding is very important to it, but we discuss other topics, and it allows people that may not feel comfortable talking about merge sort or something, but they want to talk about we were talking about computing in war, things like that, discussions about that, and they want to discuss things about how the internet works, or why is what about search engines, and all different privacy issues, and all those things. Get them engaged in technology, and I think getting them engaged in technology, even if they don't go on to become computer scientists, is not a bad thing. It's not a bad thing going forward. I do, I had a student that she graduated a couple of years now, and she was really into fashion. She wanted to be, she did a fashion blog and videos and things like that. She took the CS Principles class, and she did well. I think she got a B in the class, and she passed her AP exam. And her final project, which we call the Create task in CS Principles, was just super well done. She really put efforts into graphics and all sorts of gameplay and everything like this. And then at the end of it, she said, I don't think computer science was for me. And that's fine. She got the experience. I think maybe later, if she wanted to go into computer science, she could. Or now that she has the background, if she's working at a website that does fashion, she understands a little bit more about how websites work, and how the internet works, and how coding underneath the websites work. So it's a win that way, I think. And then we get kids that, and the other way, by the way, I have another story I'm going to keep talking, is I had a student a few years back, and she was top 5 in her class. Calc BC, student, and she took principles. Of course, she got an A, and she took the CSA class, which I call Java in our school, just for places, and got an A in that class as well. And I asked her, so did principles help you do well in this course? And she was honest. She said no, but I probably wouldn't have taken it if I didn't have the experience, the dip your feet in experience with principles to get into, to do CSA, which is very, it's harsh, right? It's newer, things like that. It's less, there's less females in that portion of the class, things like that. So it can be daunting, especially for female students.
Mm-hmm. I see. Yeah, that makes a lot of sense. And it's kind of like if you're getting into it, even if it isn't a good really good prep course, I mean, there's still a lot of inherent value in taking that. I wonder, are you familiar with sort of Dunning-Krueger effect?
No.
Okay, so this is interesting outside of CS, but also within CS. But kind of like the idea that with a little bit of knowledge, you believe that you're an expert. And essentially that mismatch is the Dunning-Krueger effect. I'm sure I gave a horrific explanation. I'm not a teacher.
Is it a good thing or a bad thing?
Not a psych teacher. Huh?
Is it a good thing or a bad thing to have this experience, to think that you're an expert?
So that's exactly the question I wanted to pose to you. It's like, you can kind of take a Codecademy course, for example, and I'm not trying to sort of like badmouth that or anything. I still, if I want to play with the language, I probably will jump into the Codecademy tutorial or some sort of similar tutorial to get my feet wet. But is it a problem where you have people who come out of that and they say, oh, I'm a Ruby programmer? Or people who come out of APCSP and think, okay, now I know how to code, I'm done.
I haven't seen that.
Okay.
I haven't seen that. I've seen, primarily with boys that have had some coding experience, not necessarily coursework, but they've tinkered at home with some coding, have all this confidence in the world, and they come into my CSA class and they don't need to do any of the homework, they don't need to do any of the assignments because they're experts, and then they get a very poor grade or a very poor score on your AP exam. So I've seen overconfidence. Most of the time I'm trying to pump up people, like, you can take this course, you'll do fine, you do all your homework, you ask questions in class. But sometimes it's the other way around, where people are overconfident in what their skill sets are, and because they're overconfident, they're not willing to work on getting more. That I've seen that both ways. I don't know if I don't have any science behind this. Anecdotally, it's usually gender-based, right? You'll get female students that are not as confident of their abilities, and then males you'll have that are overconfident.
Yeah, I know that I personally sort of had that going into APCSA because I didn't actually, unfortunately, I wasn't able to take a CSA class when I was in high school because I was super obsessed with just like doing it in my freshman year and getting it over with. And of course, they didn't let me. I was new at the school that I went to, and it was they were very really crazy about X% of people get at least a 4 or a 5. So they don't let you go into an AP class because they know, hey, if they let everyone in, then the scores are going to go down, and that's bad for our reputation. So anyway, these sort of politics of certain schools, right? But I ended up self-studying for it, and I was definitely very surprised. That was my first kind of step. I've been coding for 3 or 4 years, and I was even like doing like projects and getting paid, and then I jumped into this. I'm like, oh my god, there's so much stuff I don't know. I was even coding in Java, I remember looking things up like how do I reverse a string or whatever, those like practice prep problems, the things I'd never encountered. And it really made me question, because I think I had a bit of Dunning-Kruger at that point. I think at that point I was really, not to say that I was thought that I was like an amazing engineer, but I thought I really kind of had it down in terms of how to type things into a computer such that certain things happen on the output. And I really realized by self-studying that that was totally not the case. And I really credit that experience. I think did a lot of things for me. And I think I just like probably barely passed in terms of the score that I got. I'm sure I was teetering on the edge. And so it was interesting, like an interesting kind of foray into my first, I'd say, more academic computer science experience. That formed the basis for a lot of what we built with coding rooms. Actually, that working with people who are taking APCSA when I was in high school, and then taking it myself and stuff. So I think that was really interesting. But whenever I hear about these like various CS courses in schools, I always kind of put myself into the situation and think, if I were, X years old, what would I think of this? And a lot of times I really wonder what I would have thought about APCSP, for example, or if I were forced to take it, if there were no way for me to test out of it. I think that that's really important, like being able to test out of things, because at least my personality type, I think I definitely wouldn't have been able to sit through it. I would either be the worst student you could imagine, and totally like nuke lessons for my unfortunate teachers if I had to take APCS principles as a freshman in high school, or yeah, I would not take it at all. So I really hope that in the crazy rush to deploy CS to everyone, we still think about the huge gap between what we want everyone to have and what we want the whatever relatively small percent of people who will be career engineers to have. And like you mentioned with APCSP, that it kind of addresses that part that was previously unaddressed. I think it's only helpful insofar as it is offered as a supplementary option for people, if that makes sense. And I think that offers a little bit of a, I don't know, maybe minority sort of opinion in terms of like the background that at least that I came from, like my coding experience that I had outside of school at that point. But I think it's interesting because ultimately, with school, like you're trying to get everyone to a certain level, and then you're also really trying to push the outliers, right? And at least that's how I see education, right? It's kind of like everyone at this level, and then you need to push outliers from you need to push the people who are outliers at the bottom up to that level, and then you need to push the other outliers like way higher as well, right?
Yeah.
And so you end up with a sort of hopefully lopsided sort of bell curve type of distribution, which I just hope isn't lost in all of these discussions. And similarly, when it comes to teacher certification, because I wonder, what if like if I, after coding rooms, let's say I want to be a classroom instructor, or I want to be able to teach remotely. Something that I've personally been interested in is, could I teach remotely at 6 schools after COVID, right? I think you'd have a lot of, I honestly think you would have a lot of engineers who would be maybe not excited to do that full time, but certainly in addition some job, or if they work, and I know Microsoft has somewhat of a similar program with TEALS, but where you can provide that CS experience or that industry experience into a course, while it's still managed by, let's say, a math teacher. And then you completely get rid of this issue of math teachers not being able to teach programming effectively without like a certain number of training hours, right?
Yeah, I mean, you speak to TEALS. I think it's I've heard really good things about it. I haven't had a TEALS volunteer myself, but I've heard really good things about it, and how passionate and these professionals come in, and they come in a couple hours a day and they teach a class, and with another credential teacher in the room, and that credential teacher is learning at the same time. So that's great. At one time, I was investigating teaching the data structures class, which is for those that are in the computer sciences, is the next class in your, at least for me when I was in the semester program. It's so weird now, everybody's in quarters, I don't quite understand. But it's the next computer science course, right? It's data structures and algorithms, or data structures, or just called algorithms sometimes. And I was thinking about teaching it to high school students, and I just didn't get enough participation to offer it up. And I was going to offer it to everybody in the district. It would be on site, so somebody at a different high school would have to travel to the school, maybe do it right after school or something like this. And I just didn't get enough traction on it, not enough people on it. But the question I also had afterwards is, do they really need data structures as a 17-year-old to be successful? I mean, there are probably some people that are taking a CSA as a freshman, like you did, but to be successful, do they need to have that things? Are there other things they could be teaching that will make them successful, or that they could take that can make them successful? The calculus, the sciences, the physics, the how to write better, using an English class and things like that. So I struggle with it too, because I wanted to give that opportunity to my students, but on the other hand, I've kind of stepped back a little bit before it. Let's get it. And the other thing is, I've had students that have taken CSA as a junior, and they've taken the principles as a senior, and for the most part, it's worked out really well. So they've get engaged in the stuff that wasn't covered in computer science like I mentioned before, all those other different topics. The coding is, like my CSA class is, you will write a project that does this, and you will do it. For principles, you get to design your own class, and we're using Snap, which is a graphical program. We just touch the surface of graphics in CSA, in my class anyway. I know another teacher in the district does a lot of graphics work with it. And they ran with it. They went, instead of, they understood how loops work and everything like this. Now they went to the next level of designing great big programs and things like that. On occasion, we always talk about the student, I won't mention his name, they know so much. They got an A in my Java class, a 5 in this AP. And then when they took the principles course, they did their whole create task in 20 minutes, because they knew exactly what the minimum is that they could do to get a 5 on that, create task. So, but I'm okay with all of those situations. All the students have it. Would I love to have the opportunity for those few students that want to take, discrete mathematics and data structures? I would love to give them that opportunity to take it in high school. I would love to teach that course. But given what we are dealing with as far as how many students and enrollment and budgets and things like that, I think it kind of falls to the end. I've had students, so just to say this a little bit, I've had students that are really good students in junior year, and they became my TA or peer tutor. And in my class, they went on and did like a Coursera class in data structures, or Udacity is one of another one. So they did do those kind of things. They did it on their own. I said I could help them. I never really got around to helping them. They just did it on their own. So there are those super motivated, and there's outlets like that now, edX and all the other ones that gives those students those opportunities without taking time away from teachers that might be used elsewhere.
Mhm.
You know, ultimately, we're a finite pool of teachers, you know, and I would love to be able to have really small classes and let students teach whatever they want, but there's some practicalities that need to be there.
Mhm. I see. Yeah, that's definitely challenging. I also thought about those, like for example, data structures or discrete math course, for example. And I also have to say, I think I struggle to like see how that could be a broader curriculum thing in high school, unless unless you start doing like more of a UK model, for example, where you can drop some of the general education credits to focus on a specific vertical, right? But it really doesn't seem like the US would be really kind of into some of the model like that. I know there are some more career-oriented schools that do that, and they still issue. I assume they still issue normal standard high school diplomas, I guess. But then you could really argue that, hey, data structures isn't super career-oriented. Maybe you should focus on building apps for iOS or something. Yeah, that's interesting. That's interesting. So I guess one last wrap on the credentials discussion. Do you believe that on the exam there should be an actual coding test that teachers should be able to pass?
Oh, you know, there is no, I mean, just for California, there's no test for teachers, CS teachers currently. I know there are in other states.
Okay.
I see it on websites and things like that. So I don't know much about them. There's even practice books and stuff for them. I had to take a test to teach math. Should there be one for computer science? Perhaps. I guess I don't know the answer to that question. I think we might not get, we might lose some teachers that we wouldn't have as many of them as we need. And there is everybody tells me there is a shortage of teachers generally, but there's also going to be a teacher shortage in computer science specifically.
Okay.
So I don't know if we want to start limiting teachers that way. I think somebody can be an effective teacher especially in computer science, without understanding every little aspect of the computer science, especially at the younger level. But even at the Java level, there's resources out there. You don't have to be a computer science major or something to be an effective teacher, to encourage students to learn on their own, to be independent learners and things like that.
I see. Awesome. Thank you for that perspective. I think that really, I'm sure a lot of people would like to weigh in on that, but I maybe don't agree with all the points, but your rationale definitely makes sense for all of them. And I guess another kind of unfortunate aspect is that things are so different state by state, district by district, even school by school, which adds this really interesting and very, very complicated question of how do you develop more generalized solutions when everything is so so fragmented. But I hope that over these coming years, maybe 10 years from now, we'll be able to say, well, we're all done with CS. We figured it out. Figured out how to teach CS. Well, that'll be the case.
The district is starting to teach young kids from K, through 8th grade, and I'm enthusiastic to see what those kindergarten students that learned it a couple of years ago, when they get to my class, what are they going to be like? So it's going to be an interesting transition.
Yeah, that's really a total unknown.
Yeah.
I'm really interested to hear what that's going to be like. Yeah,
I think it'd be nice for them. They would have a confidence that they can succeed. Also, they'll have knowledge if they don't. This is not for them. So I think it's a good thing.
Mm-hmm. Awesome, awesome. We kind of like way ran over the initial time that we had set out for the podcast, but if you have a few words on, and not a few, I don't want to limit you if you have time, but if you could tell us more about your experience with robotics in the classroom, and if that's connected to what you do in APCS, or if that's sort of extracurricular. I'd love to just hear how you're doing all that, what's working.
Yeah, I can go on for a long time. So I love FIRST Robotics. I'm one of the coaches, there's two coaches at school that has, has a hardware to manufacturing, the business side, PR, and of course software. Then we do programming in Java for our robot. If any teachers are watching this, investigate it. It's very fulfilling. It's time consuming, so make sure you really know what you're getting into as far as coaching or mentoring a team. But I highly recommend it. Reach out. You're welcome to reach out to me if you have any questions about it. But as far as engaging students in STEM, I've seen nothing better. I've seen nothing better about it. So something to consider. And I'm trying to get it broadened throughout the city, San Francisco. So more and more high schools will get it. Try it and let me know if you have any questions.
Awesome. It sounds like it might be worth its own podcast.
And if you're an engineer watching this, volunteer at a robotics team. It's very fulfilling for you, and it's kind of like you work with kids and you develop get them to develop some skills, and you get learn really some cool technical stuff on your way. So that's why one of the things I'm learning so much about things that I didn't know before: motors and gears and chains and sprockets and all sorts of stuff.
Interesting. And just sort of out of curiosity, like if someone wanted to volunteer on one of these things, is it kind of happening now? I know with COVID things might be.
It is remote. It's very different. Well, most teams, okay, so the competitions are remote. So there used to be an in-person competition. It was like a big basketball game or a meet or something like this, and they're very exciting actually. Bring your younger kids; they can watch these. But some teams are completely remote. We can't meet in person, so we're doing everything on Zoom from there. Some teams are still building, like if different parts of the countries have different rules, so they are still building robots for a remote portion. How to get involved? If you go to firstinspires.org, and there's a place where you can sign up to mentor. From that, you can Google FIRST teams in your area and reach out to those teams and say, I want to mentor. And you don't have to be an expert in robotics. You can be, you just need to know more than the students, right? So you don't have to be an expert on that. Or you can be expert in PR or branding or business and things like that, and you can really give back to these students.
Awesome. Thank you for sharing those opportunities with us. I think it's probably something that I'll look into, see if I can do something here in the Bay Area with that.
Lots of good teams. If you're looking down in that area, the peninsula, there's lots of good teams and starting out teams, right? You can choose to join a team that is well established and has procedures and things, where you can come to a team that's brand new and you're getting kids on at the ground floor.
Mm-hmm. Awesome. Thank you for sharing all this with me on the podcast this time. I know it ran a bit longer, so I really appreciate your time, John.
I had fun. I had a lot of fun.
Awesome. Thank you so much. So with that, we'll end our podcast for this week, and we hope to see you again next week. Thanks.
Thank you.